All right, so part 2 to the beginning stuff at the beginning of the year before we really start to focus on the newer material, we'll say, is we got to just do a quick review of Chapter 2. So just like we did with Chapter 1 in the prereq chapter, it's all in one packet, everything's included, and it goes over a lot of vocabulary, which you want to make sure that you review again. This particular chapter focuses on functions and lines and writing equations of lines. But again, you have all of my notes prior to each of these examples as a quick little refresher. So please, again, make sure that you read through each and every one of the vocabulary that I have on here. So example number 1, it says state the domain and the range of the relation. So we're going to do that first. So domain, those are your x values. So D is equal to, we've got -4, -3, 0, 1, and 3. -4, -3, 0, 1, and 3. The range, those are your y values. So that's -2, 1, 2, and 3. And again, we do not repeat values, so don't write -2 twice. You just write them once. So we're going to state the domain and the range. Did that. Step 2 is we're going to determine whether each relation is a function. So let's go up to what a function is. So a function is a relation in which each element of the domain is paired with exactly one element of the range. So for every x, we have a matching y. Doesn't say anything about repetition, but we just know that for every single x, there's one y. And we have all x's that match with a y, so yes, it is a function for that part. Okay, now for part 3, it's asking us, okay, if it's a function, which it is, determine if it's one-to-one, onto, both, or neither. So one-to-one says each element of the domain pairs to exactly one unique, that's the keyword, one unique element of the range. So that just means the y cannot repeat. Okay, so the y cannot repeat. And then onto is each element of the range corresponds to an element of the domain. Okay, so if we look here, we say to ourselves, okay, we have, it is a function, so every x goes to a y, but the problem is we've got a repetition going on in the y value. So if that is the case, then this is not one-to-one. And you can just say you've got -4, -2, and 0, -2. So it's not one-to-one. Okay, so that one is out. We know it can't be both then, so that one is out as well. In terms of onto, it says that each element of the range corresponds to an element of the domain. Well, it doesn't say it has to be a unique element of the range, so yes, this would be onto, which means that neither would be out as well. So onto gets that choice for that part. Okay, now moving to the next topic, it's going to have you do basically evaluating. So you're given a function right here, f of x equals x squared plus 2, and you're asked to find these two items, f of 5 and f of 9. Well, if we line these up, here's f of x, and if I put f of 5 underneath it, that means that that x was now replaced with the 5, which means everywhere we see an x, we have to put a 5. So we get 5 squared plus 2, 25 and 2 make 27. So your f of 5 value is 27. For f of 9, the x now just became a 9. So we do the same thing, but we're going to sub 9 in. And we end up with 83. So f of 9 is equal to 83. And those are the two values that you would use for that particular problem. All right, shifting gears here. Now we're going to start talking about linear functions. Okay, so in the word linear, you see the word line. So that's going to help. So line means straight line, adds up to 180 in terms of geometry, but the focus is we're talking about a line. So a line follows the format y equals mx plus b. So what we're going to do for example 3, it says state whether each function is a linear function, write yes or no, and then explain. So if it is a linear function, that means we can put it in y equals mx plus b, which means we can isolate the y. That is the key. So let's see. So if we take a, if I move the 3x to the other side, becomes negative, and then if I divide by 4, to all the terms, keep in mind, I end up with this. Well, that is in y equals mx plus b. So yes, this is linear. And if you're going to explain, you can say, you can write in y equals mx plus b form. Okay, where m would be negative 3/4 and b would be equal to 3. For b, if we're going to try to isolate the y, yes, I can move the 1 over x to the other side, and I can multiply by 3. But what you're going to find is in order for this to be in y equals mx plus b, x can't be in the denominator. So in this case, this is not linear. And you can say x cannot be in the denominator. Be in the denominator. If it was in the numerator, that would be different, but it can't be in the denominator. All right, example number 4 is going to talk about something called standard form. So when we write something in standard form, looking above, we have the x, the y on the same side, and the constant is solo by itself. Okay, a, b, and c have to be integers with the greatest common factor of 1, and a has to be positive. So nothing can be a fraction, so maybe even add that. So we have no fractions, and even though it says it above, so no fractions, yikes, no fractions, and a has to be greater than 0, so it has to be positive. So when you're asked to write something in standard form, there's so many approaches or so many ways you can start it, but the key is every value has to be an integer, you can't have fractions, meaning, and the first value in front of the x can't be negative. So what you could do is, let's say we're going to move the y over first, just so that they both get on the same side, because we need them on the same side of the equation. And then there's 2 issues that are still our problem with this one. We have a negative here, and we have a 3. So in order to get rid of both of them, we're going to multiply by negative 3. And then that negative 3 has to go to all of those terms. So if we multiply by negative 3, we get 2x minus 6y equals negative 12. You go back and double check. We have no fractions, and a is positive, so we're good. So now we want to identify a, b, and c. So the format told us it goes ax plus by equals c. That is standard form. So then a would be 2, b would be negative 6, and c would be negative 12 for that. Continuing to jump, x and y-intercepts. The x-intercept is on the x-axis, so the y value is 0. The y-intercept is on the y-axis, so the x value is 0. So if we're asked to find the x and the y-intercept, for the x-intercept, we're going to set y equal to 0, and we're going to solve. So 3x minus 2 times 0 equals 24. That's gone, so x is 8. So if I make a point out of this, x is 8, and we said that y was 0. So we have the point 0 or 8, 0. For the y-intercept, we're going to set x equal to 0. So 3 times 0 minus 2y equals 24. This is gone, so y is negative 12. And we end up with 0, negative 12. Again, an x and a y-intercept, these are points.